Hi, I got a email which essentially issue was financial modeling of potential high-tech business. Let me hit F11 to put down a timestamp. Gets down to present value is one of the simplest functions, but very pervasive, and gets into the issue of the various math functions, the nature of the math of APL and through K and to CoSy. And present value, I'm going to go and show, this is old K CoSy here, and I'm hitting F9 actually for what it's worth, but here is Arthur's definition of present value in K. We'll come back to it. This is Arthur's example, which has a cash flow of 1 and 0.1 and 1.1 and time period 0 or 1, 2, and 3, and a discount rate of the inverse of 1.1. And very surprisingly, when I hit F6 in old, actually, let me hit something else first because I did that before. You can see its value is 1 here. Sorry about this, to my working size K. I still do a bunch of my accounting in K, and I'm continually, that's probably my foremost work. Just to go and give you an example, though, of the sort of math that's here. Mine is rather about n cubes and so forth, but Arthur has a whole hitting F9 here, and I'll just go and point out that all of these functions, variance, derivative, or deviations, covariance, they're all going to be essentially the same autocorrelation. They're all going to be very equivalent, as you'll about to see in CoSy, so you can almost go and look and do those conversions. For people, for convenience, I've gone and put these scripts from K CoSy over, uploaded them to my website. And one of the things, let me start by hitting F1 for help to review these the keys. F5 inserts whatever the last result was into your text. F6 is the one that really is the normal thing for evaluating a line in CoSy, and Control F6 or Shift F6 evaluates it as a raw line and leaves whatever result is on the stack, which we'll get to. But one of the things also, before it executes a line and using F6, it saves your entire environment. So if something bombs, you can come back to exactly where you were. And Control F9 actually opens up a URL, and then there are the very F11. You saw me already use F11 to put down this timestamp and save everything at this point, and that's what matters when you end up in court. And Shift F11 puts down a more complex, or more full, in this format. And F12 puts down one of these lines. So that's, and Control S also saves text when you've not executed something. But now I'm hitting Control F9 to just go and show these well, actually in RTF let's see, oh, I think, anyway, those are the URLs for these scripts. Um, and actually, I should start. I've done some updating of CoSy, so it's got more accent on the videos. Anyway, to get back here to this, so these are the K definitions here, and I won't do that's whole Arthur's example. And actually, let me come down. That was my first execution of seeing that I got the same results. Let me come down here where I've broken this down and sort of structured it in the simplest possible fashion. Sorting it out into here's the cash flow, here's the discount rate, which is 1.1, and then 1 divided. It's the reciprocal. That's the reciprocal in CoSy, and these are the time periods. And note that the paren F, well, this is one of the things because at this point in time, CoSy's working right down at the F80 at the X86 register level, and I haven't gone and generalized these or genericized these functions. So you got to tell it that you've got a float, and you've got to tell it that your operations are float or integer or whatever in general. But left is an exercise. But here I've sorted it out, and you'll see how the way that the stack works, and I'll have this a little more explicit. But when you put a number, actually this I can do. I'll put a comment symbol in there, which is the same as if I stick it on a separate line. Just doing that, that goes and does the first part. There's the inverse of 1.1, and this is one of the things that's very convenient about what's called reverse Polish. Essentially, it's read a word, do it. Simplest possible format. And there are the three time periods, and what that's going to do is this raised to the power, floating raised to the power, it's going to go and take the top 2 items that are on the stack, and it's going to take the first of them and raise them to each of the second. I'll go through this again in a moment, showing it more explicitly, and then it's going to go and take the result of that and multiply it by what's still sitting on the stack here, and at this point, well, and then it'll add them all up. So we'll get 1, which is still, I'd like to see a general formula for where that identity holds. In any case, so I've got them in the order cash flow, discount rate, and time sequence. So here I've gone and I'm not going to get too much into this, but when I talk about the stack, the fundamental structure of Forth is it's a stack machine, and you have a data stack and you have a return stack. When you go into a function, return stack has got to where it came from. And when I hit, as I showed, F6 expects a CoSy result and it outputs it to the screen, to the result. And F5 allows you to stick that result down in your text, if you want. But Shift F6 goes and executes just purely in the Forth, in Riva Forth. And if it makes a result, it'll leave that on the stack. And down here you see that there's this stack, and you'll see that change. And this word O is mainly used in debugging, but it allows me to go and Shift F6. Essentially, it outputs and duplicates the thing. So executing the first part here, we see that the result, this is what it looks like. But what it did is it created that. When it created that, it put the address on the stack. And then when we stick the next one, I execute Shift F6 this, again, it did that and it left the result you can see on the stack. And this final one, well, now we have 3 items on the stack. Now, when I do the power, it takes those top 2 and raises them to the power, and then when I do the times, it multiplied those by what those cash flows were, and then when I do the +/, and that's not going to leave anything on the stack. You can see the stack is empty now. That sort of, to me, defines a sentence. A sentence is from nothing on the stack returning to nothing on the stack. But we got the result here, 1.0, as we thought. Now, so what are these functions? I've got exponentiation and times and sum. So colon says I'm making a word, and I'll call it PV. And what it is, it's just that sequence of operations because it expects to see everything on the stack. Now I'm F6ing that, and that we put nothing on the stack, but now I'll just stick on the Forth side, PV C. C goes and shows you this is actually that's the total. That's the total actual Intel code. So now I have the word PV, and if I have these same 3 arguments and I do PV, it went and took that. One final note, actually this +/ here is a little bit tricky. You see it actually doesn't have F. It's equivalent actually to, for a float, to this, which is tick is the Forth for give me the address of the next word, which in this case is the function plus, well, floating point plus. And this is quite copied from Arthur's use of just a slash, but it means across. So this is actually summing across. So actually this line ends up being the same, and bang. So I think that's quite a bit. Post any questions that you have or further issues or comments. But I'm going to close this off right now. And with one final comment that is becoming, if it is something that I have to bill on, I just put colons on my timestamps, and it's quite trivial to add up my on-clock time. Thanks. Bye. Yeah, check out CoSy. It's new on the planet.